Hello and welcome to this lecture. We are going to discuss conditioning with multiple discrete random variables. Okay, so like I said, marginalization is one key idea to sort of reduce the scale of the problem, look at a smaller problem from a bigger problem. Okay, that's always very nice. But conditioning is what connects the marginals to give you some picture of the whole in some sense, right? So that's important also. Okay. We've seen before how the joint PMF of two random variables is the product of the marginal times the conditional, right? So you can see that the conditional is sort of like a bridge between marginal and joint. Okay, so that's an important maybe principle to keep in mind. Okay, so when you have multiple random variables, let's say here's the example here. I'm starting with an example of 4 x1, x2, x3, x4. You can do all sorts of conditioning. Okay. So, I mean, previously we saw when you had two random variables x and y, you could do x given y given x. That's it, right? So now with multiple random variables, you can do variety of conditioning. Let me give you the simplest example. Okay. So the simplest example we've seen this before, right? You just take two of them, x1 and x2, and look at this random variable, the conditional random variable that I've been talking about, x1 given x2 equals t2. Okay, that has a PMF which we write as fx1 given x2 equals t2 of t1, right? So that's how we write it, and we know that this is just the joint divided by the marginal. Okay, conditional equals joint by marginal. Okay, so that's a very nice formula to remember. Joint equals conditional times marginal. Okay, that's also a nice formula to remember, but conditional equals joint by marginal. It's a very nice simple thing to remember. And notice how the joint came, right? You took x1, x2 and simply joined it, put it on the numerator, and the conditioning alone you kept in the denominator. Okay, so this simple idea one can extend not just with two random variables, even if you have more than two. So let's say I want to define a pair of conditional random variables in some sense, right? x1 comma x2 given x3 equals t3. Okay, so remember, see, all these things are random variables on the same space, and I have events defined using x3, right? That's what I'm doing here. And once I define an event using x3, I can of course condition the random variables x1, x2 conditioned on that event. Okay, I'm looking at both of them conditioned on that event. That's all. Okay, so it's all valid and clear and very easy things to think of in some sense. Okay, so I can think of the x1, x2 given x3 equals t3. So this is like a joint distribution of x1 and x2 conditional on x3 being t3. Okay, joint PMF of x1 and x2 conditional on x3 being t3, isn't it? It's maybe a bit confusing, but you can see that the idea is very similar to the conditioning of x1 with x2. Okay, and the formula is also very similar. It's the same principle, joint by marginal, joint by marginal. Okay, so what is the joint? I have x1, x2 given x3 equals t3 of t1, t2. I simply join everything, put it in the numerator, right? x1, x2, x3 of t1, t2, t3. You divide by whatever you're conditioning on, right? So fx3 of t3. Okay, simple enough, right? So it's just simple extension, and you can show that these are all valid. They satisfy all the conditions of the PMF, right? Their values between 0 and 1, and they add up to 1. Okay, all of these can be quite very reasonably shown. It's not a big problem to do that. Okay, let's look at the next one. This one is a little bit more interesting, right? So I'm going to condition on a slightly more complex event. What is the event? The event is that x2 equals t2 and x3 equals t3. That's the event. Okay, I'm taking that event and I'm conditioning the random variable x1 given that. Okay, so x1 given this event x2 equals t2 comma x3 equals t3. How do I write the distribution for this? The notation is again a little bit cumbersome, but it's easy to write down. F x1 given x2 equals t2 comma x3 equals t3 evaluated at t1. That is simply once again the joint by marginal. Nothing more to worry about, right? What is the joint? Just combine everything together, x1, x2, x3 of t1 comma t2 comma t3. And what is the marginal? What comes in the denominator? Whatever you're conditioning on, right? So x2, x3 of t2 comma t3. Okay, so it's very easy to write down these conditional expressions. Okay, you can also do some more flavor, more interesting variety here. So here is the joint distribution of x1 and x3, joint PMF of x1 and x3 conditioned on the event that x2 equals t2, x4 equals t4. Once again, one can write a joint PMF, joint conditional PMF x1, x3 given x2 equals t2, x4 equals t4 of t1 comma t3, right? So it's complex, unwieldy sort of expression. I'm just writing it like this. There are some simplifications here, but anything here is unwieldy, so we'll just live with it. Okay, and once again, the principle, I mean, how do you write the joint PMF? It's joint, how do you write the conditional PMF? Is joint by marginal, okay. So you take x1, x2, x3, x4, combine all of them, do T1, T2, T3, T4 divided by whatever you are conditioning on, okay. Simple, right? It's almost like, it's the formula itself is so simple that you can teach anybody, but how it connects to practice is where all the difficulties will come. We'll see, okay. Conditioning with multiple discrete random variables, okay. So this is done. Let's see an example, okay. This is a slightly more complicated example. So you can see, I thought I should do one worked out example, try a few cases, and at least evaluate a few probabilities, few joint PMF values to show you how this this will work out in terms of flavor. You'll see it's a bit confusing sometimes, but it's worth it, okay. So let's start with what? Let's start at the very beginning. So we'll start with x1 given x2 equals 0, okay. So first thing you have to do is sort of identify the range, right. So let me remind you of when somebody gives you a big table of values and things like that, the first is to look at every column, identify the range, make sure you understand what values it takes and all that, so that you can start working on the problem, right. The first thing is I've identified here that tx1 is 0, 1, right. So identify the range, and this is also tx2, okay, and you can see also that this is tx4, right. So three of them have the same range, and the range of x3 is 0, 1, 2, okay. Quick things to identify, always start whenever you have a random variable problem, start with the range. Range is easy to write down, so let's just write that down first, okay. And then I'm going to start looking at, I'm dealing with conditioning here, so let's say I want to look at x1 given x2 equals 0, okay. So maybe not, let me not write down the PMF here. So let's look at x1 given x2 equals 0, okay. So this guy, so given x2 is 0, I know I can only, it's enough to look at the case where x2 is 0, okay. So this guy and this guy, that's it, I don't have to worry about anything else, okay. So I know the probability, the PMF of x1 given x2 equals 0, okay, evaluated at say 0 is the joint of x1 x2 of 0 comma 0 divided by the marginal x2 of 0, okay. So you look at how many cases you have x1 equals x2 equals 0, right. So if you look at this distribution, I know it takes two values 0 and 1, okay. So given that x2 is 0, I am seeing that x1 takes value 0 sometimes, takes value 1 sometimes, right. So that's the first thing. So you identify the range of the conditional random variable also, okay. You identified the overall range, that's okay. Then a particular conditioning, if I ask you, identify the range of that object, okay. How do you identify the range? You just focus on what you've conditioned on, okay. This is x2 equals 0, and then see what are the values that x1 takes for those particular conditioned situation, right. So when x2 is 0, you see that x1 can take value 0 and it can also take value 1, okay. So 0 and 1. The next step is to find the probabilities, okay, the conditional, the actual PMF, the conditional PMF values for 0 and 1. For 0, what do? You look at 0, 0, the cases where you have 0, 0 for both x1, x2 divided by the total probability of x2 equals 0, right. So that you will have, so that there are 7 cases. So in the denominator you will have 7 by 12, in the numerator you will have 4 by 12, right. So this 0 case is just 4 by 12 by 7 by 12. Okay, maybe I should write this down more cleanly. 7 by 12, okay. And what about 1? 1 is 3 by 12 by 7 by 12, okay. So hopefully you see how I got that. For the conditional random variable to take the value 0, I have to look at the case where x1 and x2 both take 0, that is 4 out of the 4 by 12, right, probability is 4 by 12, and then I have to divide by the probability that x2 is 0, that is 7 out of 12, isn't it, okay. So hopefully you saw that. Same thing with 1, I will get 3 by 12 and 7 by 12, okay. So let's look at slightly more confusing situation. So let's say x1 given x3 is 0 and x4 is 1, okay. Look at this. So maybe I should write this in, let me just me just write this in some other color. We'll pick a blue color. x1 given x3 is 0, x4 is 1. Okay. What is x3 0, x4 1? That's here, right? That's here. Notice what's, okay, there's one more here. Sorry, forgot this. Okay. So this number of cases is, sharply decreasing, even in this table. But anyway, it's there. So we see here that this corresponds to 0. These two correspond to 1. Okay. So the range is 0, 1 again. Okay. And what about the probability? Okay. The 0, 1 case appeared 3 times, that's like 3 out of 12. And then 0 appeared in 1 out of 12. So that works out as 1 by 3, isn't it? Just cutting it down. So once I have 1 by 3 here, there are only 2 values. The other thing should be 2 by 3, right? I don't need to, work out that at all. Once I get 1 by 3, I know the next one is 2 by 3. So it's a valid PMF, it needs to be a valid PMF, so that's enough. Okay. So that was just one slightly more confusing situation. Let's look at something a bit more interesting maybe. Okay. Maybe we'll look at this case. Let's look at x3, x4 given x1 equals 0. Okay, so this is something I'm going to look at. So I'll have a table of possibilities here. So I should put some T4, T3 here and T4 here. Okay. Now given x1 is 0 is all of these guys. And if I want to look at x3, x4, I have x3 taking values 0, 1, 2. I have x4 taking values 0, 1. So x3 is 0, 1, 2 and x4 is 0, 1. Okay. And if I look at 0, 0, that is 1 out of the 7 cases here, right? So you can do it more carefully. You can do 7 by 12 in the denominator, 1 by 12 in the numerator. We'll get the same answer. Okay. T3 is 0, T4 is 1. That is again 1 by 7, right? T3 is 1 and T4 is 0. That's again 1 by 7. 1, 1 again happens 2 by 7, right? So it happens twice. It happens once here and once there. And then 2, 0, that happens twice again. That's 2 by 7. And 2, 1 never happens. Okay. So you see here it works out to be a joint PMF in this way. Okay. So this is an important, simple, basic skill in conditioning and all that. Given a table or given the joint PMF, marginalize and find whatever conditional you want, whatever marginal you want. Hopefully this is easy to do in some sense, and it's just a question of carefully identifying and summing up the probabilities. In the uniform case, it's very easy. If it's not uniform and all that, you have to add up, and if it's a more complicated joint PMF, it's really, really painful, but it's easy enough to do, and the principle is important. Okay. Okay. So the next important thing is the conditioning, the conditional PMFs and the marginal PMFs are related to the factoring of the joint PMF. So what is factoring of anything? If you take a big number, the number seems very big, but if you keep factoring it, you can write it as a product of various small numbers, right? So even though like a number like 1024 seems very large, but actually it is 2 into 2 into 2 into 2 10 times. If you do that, you get 1024. It seems like if you say the description is 2 into 2 into 2 10 times, it seems a bit simpler than 1024 in some sense, right? So that way, if you look at a complicated big joint PMF, which we are not able to understand, or maybe it's very confusing, if you can factor it, if you can write it as a product of several terms, and each term maybe is okay in some level, you can deal with it in some reasonable way, then there is some hope that you can deal with the joint PMF. Okay, so factoring the joint PMF is a hugely important idea in understanding a stochastic phenomena with many different random variables. You don't want to look at just the joint one. You want to see if you can factor, if you can think of the factors in some way. Okay, so for that, this marginal and conditioning idea is very, very crucial. It turns out you can do factoring in so many different ways, and I'll talk about some very important special cases later. Okay, but where does the fundamental idea come from? It's actually a very simple idea. We use the marginals and conditioning that we saw so far, and we write it as a factor. Okay, so let's look at a simple example. Okay, so here are 4 random variables x1, x2, x3, x4, and I have a joint PMF f x1, x2, x3, x4. There is some range, etc. All of that is okay. I know that the joint PMF evaluated at T1, T2, T3, T4 is simply probability that x1 equals T1 and x2 equals T2 and x3 equals T3 and x4 equals T4, right? So this is easy enough to write down. Okay, so now I'll start putting these brackets. Okay, so notice this and is and, I mean it's and of everything together, so it doesn't matter if I take the and of x2, x3, x4, those things first and then do an and with this. It's the same, right? So everything has to be true, so it better be true in that way. So now I have an and of 2 things and I can do conditioning. Okay, so notice how I do conditioning here. I can do probability of x1 equals T1 given x2 equals T2 and x3 equals T3 and x4 equals T4 times probability of x2 equals T2, x3 equals T3, x4 equals T4. I have achieved one factoring. Right, I have written the joint PMF as the product of 2 things, but next what do I have? I can now repeat this, right? I have probability of x2 equals T2, x3 equals T3, x4 equals T4. I can do bracketing, conditioning and multiplication. x2 equals T2 given x3 equals T3, x4 equals T4 times P of x3 equals T3, comma x4 equals T4. Okay, so notice how conditioning is helping me out. I have written the joint PMF as a product of 4 factors. The first factor is x1 equals T1 given all the rest, or actually maybe it's better to read it in reverse, no? x4 equals T4, right? The marginal of x4 equals T4, then x3 equals T3 given x4 equals T4, and x2 equals T2 given x3 equals T3, T4, and then x1 equals T1 given all of them. Okay, so it's a very nice and simple thing. I can now write it in terms of my conditional PMFs that I know how to calculate, and I have a product of 4 conditional PMFs and 1 marginal and 3 conditional PMFs. Okay, so this kind of factoring is very, very, very useful to understand complicated joint PMFs. I mean, you may have a lot of random variable and the joint PMF is very difficult to understand. So you may be able to write these things as product of marginals. Maybe the conditionals are still difficult to understand. I'm not saying no, but at least it gives you a sense of maybe some approximation, maybe something you get an idea of. Okay, so we'll explore this idea more later on, but let's focus on the factoring for now. Okay, the factoring itself seems to have enough variety here. So let me show you some examples of this factoring and show how particular cases it works out like that. So let's look at the case where we have I want to look at f x1, x2, x3. Let's start with the simplest possible one, 0, 0, 0, right? So I know I can write this as f x3 of 0 times f x2 given x3 equals 0 of 0 times f x1 given x2 equals 0, x3 equals 0 of 0. Okay, so let's verify this. So this we know is 1 by 9. What is x3 of 0? So let's look at x3 equals 0, and that is this, this and this. Okay, there are 3 possible cases where x3 is 0, so that's 3 by 9. And then I have x2 given x3 is 0. Okay, so and then x2 is 0 given x3 is 0. Okay, given x3 is 0, x2 is 0, let's change the color here. This is this guy and this guy, isn't it? So given x3 is 0, that is 3 by 9, and x2 is 0 for 2 by 9 of those cases, so you get 2 by 3, right? So 2 by 9 by 3 by 9, you get 2 by 3. So let's come to this last case. Maybe I'll use my next color here. x2 is 0, x3 is 0, that's this what I had in green here, and then if you look at that case, that is the case when x1 is 0, so that works out to be 1 by 2. Okay, and you can see 1 by 9 is 3 by 9 into 2 by 3 into 1 by 2. Okay. So, it is easy enough to check this factoring. It has to be true, and I hope I convinced you that if you do it in for any other value, I did it for 0 0 0, you can do it for any other value, you know, 0 1 1, 0 0 2, you pick your favorite value and try and practice this calculation, you will see it will work out. Okay. So, it is easy enough. Okay. Now, here is what is something that is more interesting. I did it in one particular sequence, right? I did T1, T2, T3, T4, and it turns out you can do it in any sequence. Okay, see, the AND is the AND in any other sequence, right? So, instead of doing x1, x2, x3, x4, I can do x4 equals T4 and x3 equals T3, just reorder the ANDing. I mean, I can AND in any way, so it's AND of everything, right? So, if I do that, then repeat the same thing as before, right? x4 given x3, x2, x1, then x3 given x2, x1, then x2 given x1 and x1. Now, I get it in this form. Okay. So, I can first do marginal of x1 and then conditional of x2 given x1, then conditional of x3 given x1, x2, and then conditional of x4 given x1, x2, x3. That is also possible, right? It's the same thing I have written down. I have done it in some other order. You can do it in one more order. I mean, why you stick to just 1, 2, 3, 4 or 4, 3, 2, 1? Let me do 3, 2, 1, 4. Okay, why not? Okay, I am just ANDing. I can do it in any order I want. Okay, I can do marginal of x4 times x1 given x4, then x2 given x1, x4, x3 given x2, x1, x4. You can go in any order that you like, and you will get the exact same answer. Okay. So, let us try that. Okay. So, previously I went 3, 2, 1, let me go 1, 2, 3. Okay. So, let me show you how that is done. So, let us say I want to look at the same evaluation. I did x1, x2, x3 of 0, 0, 0. I am going to do it as f x1 of 0. Just to be sure, let me just check what I did before. I showed you x3, x2 given x3 and then x1 given x2, x3, right. So, I am going to do it in reverse here. I will do x1 and then x2 given x1 equals 0 of 0, the same calculation just to convince you that you will get the same answer of 0. Okay. So, let us do our little multicolor presentation once again. x1 is 0 is all these guys, that is 5 by 9. x2 given that one. So, if you want to look at this guy, x2 given x1 is 0, you will get, you have to look at this possibility, right. x2 equals 0 given x1 is 0, that is 3 out of 5, isn't it. You can divide carefully if you want, you divide by 5 by 9 and then the numerator you will have x1 and x2 both being 0, the joint PMF, that is 3 by 9, you will get 3 by 5, and then let me pick my third color for this. x3 given x1, x2 is 0, and that is just, yeah, I think it is this one. Okay. Yeah, I am sorry, I think I missed this a little bit. There are 3 cases here, and then you know this is the favorable case. There are 3, x1, x2 being 0. And x3 being 0 is only one of them, so you will get 1 by 3. So, you can repeat this calculation more carefully. So, if you multiply it out 5 by 9, 3 by 5, 1 by 3, very well you get 1 by 9, which is what you know is the answer. Okay. Okay. So, you can check this in any other way. You can take anything else, do it in any other sequence, you will get the same answer. You will get the same answer, right. So, these are identities which are always true. Okay. Okay. So, okay, all right. So, I think so that I would like to stop with conditional distributions with this lecture. Hopefully, you saw the utility of it. Okay, so we will see soon enough some actual practical uses for these kind of ideas. But the factoring of a joint PMF into multiple factors as marginals and conditionals is a very, very powerful idea. It helps simplify a lot of calculations and formulations and modeling and all that. Okay, so we'll pick up from here in the next class. Thank you very much.